Hello everyone, this is Amin Nasif Zawad and today I'm back again with another chemistry video. In today's lecture, we are going to have our second class on quantitative chemistry. Previously, we have learned how to calculate the relative formula mass, the moles, Avogadro constant, and also the conservation of mass. And in today's class, we're going to learn how to find out and calculate the number of moles that is present in a certain amount of mass of an element or compound. So, without any further ado, let us get started. So, to calculate the number of moles in elements, we have a specific formula. That is, the number of moles is equals to mass divided by relative atomic mass. So, to find out the number of moles that is presented in a certain mass of elements, we will need the mass that is given in the question and the relative atomic mass of that certain element. For example, we're given with 32 grams of oxygen. So, we will need the mass, 32 grams of oxygen, divided by the relative atomic mass of oxygen. So as we know, the relative atomic mass of oxygen is 16. This is found in the periodic table, which we will be given in our exam and questions. So 32 is the mass divided by 16, that the relative atomic mass. So 32 divided by 16 equals to 2. So the number of moles in 32 grams of oxygen is 2. The calculation and the formula will become more clear as we will move on to the examples or written examples in the next slide. Now let us look at the two written examples in this slide. The first question: how many moles are there in 120 grams of calcium? As you can see in the question, 120 grams, the mass is already given, and we know the relative atomic mass of calcium. This is found in the periodic table, as I have said before. So we have the mass, we have the relative atomic mass. Now let's input the formula. Number of moles equals to mass divided by relative atomic mass. We have the mass, that is 120 grams, divided by the relative atomic mass 40. So 120 grams divided by 40, we have 3. So as you can see, we can easily find out the number of moles by inputting a simple formula. So we have gotten the answer 3. So 3 moles are present in 120 grams of calcium. Now let us look at another example. How many moles are there in 162 grams of aluminium? So the mass is already given, 162 grams of aluminium, and we know the relative atomic mass of aluminium, that is 27. Now, as before, let's put the formula. Number of moles is equals to mass divided by relative atomic mass. The mass is already given, 162 grams, divided by 27, the relative atomic mass. So, after calculations, we get 6. So, 6 moles are there in 162 grams of aluminium. As simple as that. So, by inputting the formula, which is number of moles equals to mass divided by relative atomic mass, we can easily find out the number of moles that are present in a certain mass of an element. Now, as we have learned the calculation of moles in elements, let us learn the calculation of moles in compounds. As you can see, we have another formula for calculation of moles in compounds, that is mass divided by relative formula mass. As you can see and notice and observe that the formulas to calculate moles in elements and compounds are very, very similar. Yes, the only difference is that in elements, we calculate the moles by dividing mass with relative atomic mass, that is the atomic mass element has, but in compounds, we deal with it by dividing mass with relative formula mass. We have already learned how to calculate relative formula mass. Relative formula mass is basically the relative atomic mass of all those elements present in that compound combined. So to find out the number of moles in a compound, we divide the mass by relative formula mass. Now we'll be seeing some examples. Now here we have an example of the calculation of the number of moles in a compound. So let us read the question first. How many moles are there in 60 grams of sodium hydroxide? Since sodium hydroxide is a compound, we already know that the formula for this will be mass divided by relative formula mass. So in case of the elements, the first thing we did was input the formula, mass divided by relative atomic mass, and then we did the calculations. Simple. But in case of sodium hydroxide, which is a compound, we first need to find out the relative formula mass. We already know how to find out the relative formula mass. That is, first write down the element that it has in a compound and then its relative atomic mass. So we note down the elements that sodium hydroxide has, that is sodium, oxygen, and hydrogen. Sodium has a relative atomic mass of 23, oxygen has 16, and hydrogen has a relative atomic mass of 1. So we know what to do. Add them up. 23 plus 16 plus 1 equals to 40. So now we have the relative formula mass for sodium hydroxide, which we found by adding the relative atomic mass of the elements in sodium hydroxide. Now input the formula. Number of moles equals to mass divided by the relative formula mass. We know the mass is 60 grams as given in the question. We have found out the relative formula mass, 40. So 60 grams divided by 40 gram per mole, and then we get 1.5. So there are 1.5 moles in 60 grams of sodium hydroxide. That is how we find the number of moles in a compound. I hope that explanation was clear. With this, I have come to the very end of this lecture. I hope you understood what I said and you enjoyed this class. If you have any queries, comment down below. This is Nasif Zawad signing off from Alasamadaid.